60, 90 triangles. So the way we can start, which is pretty normal, pretty typical, is we start with this equilateral triangle here. And what we do is we assume that the sides have all the same length, and we assign 2. I mean, it doesn't matter, except it makes it easier if we make 2. And then what we do is we bisect the angle, and that splits the opposite side into pieces here that are the same length. And we could do a little proof to show that's true but let's not do that. I mean, you can use side angle side and show these two triangles are congruent. So that if this line segment bisects the angle here, it should also bisect the other side, because these two triangles would be congruent. But so what we get then is, if we now just only look at one of these triangles, that's a 30, 60, 90 triangle, and we've already gotten 2 of the sides, and to find the third side, we can just use the Pythagorean theorem. So it's, sort of elementary, it's sort of cool. Then, so you get h squared is 4 minus 1, and then we only take the positive root, so we get radical 3. Now, we also see that, okay, well, let me also, before I was going to start on something else, but let me just turn this on its side, same triangle, but you put it on its side. And one thing to keep in mind is that square root of 3 is greater than 1. You can think of square root of 1 as the square root of 1. Square root of 3 is greater than square root of 1. So the opposite, the smaller angle is the shorter side. Opposite the larger angle is the longer side. And so we can then find sine 60 degrees, cosine 60 degrees, tan 60 degrees, and we can just refer to those triangles. So sine is opposite over adjacent, cosine is hypotenuse, sorry, I said that wrong. Sine is opposite over hypotenuse, I wrote the right thing. Cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. Should I have written that down? So this is opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, opposite over adjacent. And then if I can also find values for sine, cosine, and tangent for 30 degrees. It's the same triangle, and one of the things we can notice as we're going to lead into this is that 30 plus 60 makes 90. That's obvious, and it's right there. And what is opposite a 30-degree angle is adjacent to the 60-degree angle. So we'll get into that in another video. But for opposite over hypotenuse for sine, we're going to get 1/2. Adjacent over hypotenuse is rad 3 over 2. And then opposite over adjacent is 1 over rad 3. We can also write, okay, what we can do is, I'm going to see if I can fit this in here, is we can write these same triangles so that their hypotenuse is 1. And there's reasons we like to do that. So how would you what's going on there? Well, you take this triangle here and you divide everything by 2. And you're going to get a triangle that's similar, so the ratios all hold up. You're just scaling it down by 1/2. You multiply it by 1/2. and you're going to get all these numbers just by dividing by 2. And so there's a lot of cases when it's more it's advantageous to have the hypotenuse as 1. Sort of just depends. But here the thing is that these sides are fractions, so fractions can be sometimes a challenge to work with.